Okay, this video is about homework 5, and a lot of people had questions about this homework, so I thought I'd post a short video about it. Group Homework 5 General Instructions is the file that's on Blackboard. It kind of takes you to the steps you need to complete for this assignment. But with some of these, it may be a little difficult to find the variables that you need for the different steps. So first I'll go through what those variables would look like, and then talk a little bit about these steps you take and show a graph that kind of shows what the total costs look like with different order quantities. So you may have a better idea of what you're trying to accomplish with this homework assignment. Okay, so first off, you need to calculate the economic order quantity, assuming no quantity discounts on the purchase price, and of course EOQ does not include transportation price, so we wouldn't worry about the quantity discounts on those either. So the basic EOQ formula, EOQ equals the square root of 2ds over IC. Demand would be their estimated demand for the next year, 4,000 units per year. Ordering costs, given these numbers are all given in the assignment if you read through the case, but some of them are more difficult to find than others. Ordering cost is $75 per order. Inventory carrying rate is 20%, or 0.20. And the purchase price or cost of the items, the television in this case, was $1,200. So you can plug those numbers into the EOQ formula and come up with an order quantity. And what that quantity says is if there were no quantity discounts on transportation or purchase price, this would be the optimal order quantity to order every time you placed an order. So the strategy would be to order this number of units every time you placed an order. Of course, you'd use the reorder point formula to figure out when you would place that order, but that's not really necessarily relevant to this problem. Okay. The next step is you want to figure out what is the total cost, including transportation costs and safety stock and purchase price, because we can get discounts or differences in all those items by using different order quantities. For example, if we ordered less than a full truckload, we would probably use the less than truckload carrier. They call it mainline. If we ordered 500 units or 1,000 or 1,500 or 2,500 in full truckloads, we would probably order from the truckload carrier. And actually, if you calculate the prices, anything over 400 units, it would be cheaper per unit to order by the truckload carrier, even if you didn't fill up the truck. But it doesn't really play into the scenario here very much. So first thing we want to calculate is safety stock. Safety stock is Z, some Z value that would correspond to a in-stock percentage you would like to achieve on an item. Because this company seems to be very worried about having a high in-stock percentage, I chose Z of 2.0, which corresponds to a 98% in-stock level. So very high in-stock level with this safety stock. And you multiply that Z score, and you can find this in a normal distribution table that's available on Blackboard. But you just go ahead and use this number if you want to. You'd multiply that Z score times the standard deviation of lead time demand, or demand during lead time. So that's what we need to figure out. If you remember from class, the formula to estimate demand during lead time or variation, the variation would be the square. This is, of course, a standard deviation of demand during lead time. So we need to know the average lead time. Of course, this varies between Mainline and Hayes, the two transportation companies. We need to know the variance of daily demand, or this is standard deviation squared, same as the variance. We need to know the average daily demand, and we need to know the standard deviation of lead time, or the variance of lead time, because it's standard deviation squared. Right, so when we square this term, it becomes variance. This whole term, sigma LT squared, is the variance of lead time. Okay, so for both carriers, though, we have not only the lead time from the carrier, but also the lead time from the supplier. So for Mainline, it was given there's 3.5 is their average transit time, 3.5 days. The supplier's order processing time is 3 days, regardless of the carrier. So that gives you 3.5 plus 3. It takes about 6.5 days to get an order in through Mainline. On average with Hayes, it's 5 days plus 3 days from the supplier, so 8 days. So not a big difference in the average lead time. Okay. Now the standard deviation of lead time gets a little bit more complicated because you're combining two random variables and the variance of those. That's what you're trying to calculate. So I'll get to that, and then I'll show the numbers at the end of the sheet. Okay. I just want to know, what is the average daily demand? We're given weekly demand of 75 units is what we're forecasting. Now, if you just assume a 5-day work week, which is pretty typical of a wholesaler, you just divide 75 by 5, gives you 15 units per day. Then we want to know, what is the standard deviation of that daily demand. We know the standard deviation of weekly demand is 20 units, but we want to know, what is the standard deviation of daily demand. Of course, if we assume a 5-day work week, daily demand is 1/5 of a weekly demand. A day is 1/5 of a week. So what we're really need to figure out first is the variation of a constant times a random variable. The constant is 1/5 of a week. The constant variable is demand. So this formula basically says the variation of 1/5 times demand is 1/5 squared times the variation of demand. If we want to know standard deviation, we take the square root of this 1/5 squared times the variation of daily demand, which is standard deviation of 20 we were given, times or squared. So we basically have 400 divided by 25, gives the square root of 16, gives us 4. So the variation of daily demand is 4. The average daily demand is 15. So we get nice whole numbers to work with there. So then the difficult part is trying to figure out the standard deviation of lead time, because we're dealing with combining two random variables. The supplier has an average of 3-day lead time with a 1-day standard deviation. The transportation companies have average of 3.5 and 5 days lead time with a 0.5 and 3.3 standard deviations. Okay, so I'm going to talk briefly about how you calculate that number. Standard deviation of lead time, when to combine the variation from the supplier and the transport company. The way you can do that, the rule from statistics says the variation of x plus y, these are two random variables. In this case we'll say x is the transportation company and y is the supplier, equals the variation of x, which we're given, plus the variation of y, which we're given. So the variation of or we're given the standard deviation. You square standard deviation to get variance, plus the covariance of x, y. Now we're going to assume that this transportation companies and the supplier are independent, which means the distribution of their lead time should be independent, so there should be no covariance. So this covariance becomes 0. We're looking at the variation of x plus y equals the variance of x plus the variance of y. So if you wanted to find the standard deviation, which we need for our formula, of x plus y, or standard deviation of the lead time from the transportation company and the supplier, we've got the standard deviation squared from the transport company, 0.5 squared. We've got the standard deviation from the supplier, squared, 1 squared. So together, of course, this comes to 1.25. Take the square root, you get about 1.12. That should be close enough for our estimates. Because remember, my formula that we're using to estimate standard deviation of lead time demand tends to overestimate that. So we will say it's close enough. We'll just round that off. For Hayes, you had a standard deviation of 3.3 days. You square that, plus the supplier still had the 1-day standard deviation of their lead time. So you have 3.3 squared plus 1. Take the square root of that to get standard deviation, and you get 3.45. So then this is just to show you all those numbers you would need to estimate the standard deviation of lead time demand. Average lead time for mainline, standard deviation of lead time for mainline. Average lead time from Hayes, standard deviation of lead time from Hayes. Average demand, daily demand, standard deviation of daily demand. So we had to do a few calculations to get to these, but these are the numbers you need. Again, you can find all of the numbers I used in the case, but this I thought might make it a little easier. Okay, so what you want to then do, go back to the directions, is first calculate the EOQ using those numbers I just gave you or from the case. Calculate safety stock required for less than truckload and for truckload, because that would vary. You can just 2 for Z and use the numbers I gave you previously for this. Okay, so then we want to say, what is the total cost if we use this economic order quantity? What would our total costs be? Okay, so for that, we need to think about transport costs and purchase price. And what I have here, T is transport cost per unit, D is annual demand. Regardless of when they come, we're going to ship 4,000 units to our warehouse so that we can sell them to our customers. We're also going to purchase 4,000 units, so 4,000 is D, C is 1,200 for this. Transport cost per unit we would calculate from the problem. Okay, so for the economic order quantity, calculate total cost. And let's just say EOQ came out to be 65 units. Well, we know from looking at the chart from the case and from the transport company, if we were to calculate the cost, we would take 40% of the given cost per hundredweight, divide that by 2, and that would give us a cost per unit. So, for example, if the cost per hundredweight is 100, you would actually pay 40% of that because of the 60% discount, so that's 40. Divide that by 2, it would give you $20 per unit transport cost. And there aren't any cases where that was the price, but that's how you would calculate it. So let's suppose EOQ was 65 units. We know that if you order more than the EOQ, your total cost will increase. And if we're not getting a discount on transportation or purchase price, we will see no benefit. But we also know that we could get a lower transport rate if we order 100 units, or if we order 200 units, or different quantities. So we do need to go ahead and say, we know what the EOQ is. If it was 65, that's fine. We know if we order less than that, we'll just pay more money because transport costs go up, not down. The sum of ordering and carrying costs would go up, not down. But we could say, what about at 100 units? If we ship 100 units, and technically from the case I guess would be 101, but to make it easier I'd say 100 units, just for calculating. If we ship 100 units at a time, we get a lower transport rate. We will be ordering more than the EOQ, so we'll be paying more on inventory carrying costs and ordering costs. But those additional costs may be offset by the reduction in transport costs. So we need to go ahead and come back to our total cost formula. And so using EOQ here, we would then use 100 for Q in the LTL safety stock we calculated. Change the transport cost to the lower rate. Costs stay the same. D is 4,000 in all of these calculations. I and C stay the same for all the calculations, or I and S. C, when we start looking at quantity discounts, C would change it. Okay. And then we say, well, at 200 units, we get an even bigger discount, so let's check it there. And then we say, well, if we fill up a truckload, we're going to ship at about $4.50 per unit, lower price, so let's check what that is. Right, now, if we ordered 501 units, we're actually going to pay for 2 trucks and only ship 1 additional unit, so it'd be really expensive. Or we could ship 500 by truckload and 1 unit by LTL. But we assume they'll only use truckload for full or nearly full loads to minimize the transport cost. Okay, so we check out 500 units. Right, so that is small quantities we checked at, all the different transport rates, same price, purchase price $1,200. Then we'd say, okay, right, so each of these cases, when you switch to a truckload, right, you're going to change the safety stock out to the truckload safety stock numbers. Change the transport cost to the truckload price. Right, change the demand or the quantity to 500 units. But we also know that if they order 1,500 units, they'll get an additional discount on the price per unit. So we check total cost at 1,500 units, and 2,500 units where they get an even bigger discount. So we can check at EOQ, which is somewhere between 40 and 100 units. Check at 100, check at 200, 500, 1,500, and 2,500. Any of these variables that change, for example, at 1,500 units, C would change. Right, so change those in your formula. Figure out which order quantity gives you the minimum total cost, the minimum of this formula. Okay. Just to make things a little bit easier, I went ahead and calculated the actual shipping cost and the purchase price. For less than 1,500 units, you spend $1,200 per unit. If you order 1,500 but less than 2,500, you just pay $1,170. It's a 2.5% discount. If you order 2,500 or more, you pay $1,140. It's a 5% discount. For transportation costs, okay, these are price per hundredweight. If you look at the left side of the table this comes from, you'll see these are different weights that would qualify for this rate. So if TVs are 50 pounds, you can divide those weights by 50 to figure out what quantities you're talking about. But basically, this is the rate for less than 10 units. This is the rate for anywhere between 10 and 20 units. This is the rate for 20 to 40 units, 40 to 100 units, 100 to 200 units, and 200 plus units. For truckload, as long as we're shipping in full truckloads, the points we're checking, 500, 1500, and 2500 units are all full truckloads. This is the cost per unit. It comes out to $4.50. Right? If we ship, say, 510 units, we'd have to say 2250 times 2 divided by 510, or we could say 450 per unit, or 2250 for the first 500, and then 996 per unit times 10 units, and divide that by 510. We know it costs more, so we're not going to really look at those. We know ordering 500 is better than ordering 510. Now, actually, with these rates, if you order more than 400 units, up to 500, you're actually paying less for using a full truckload than LTL. But that's not really necessary to calculate for this. Okay, just going to give you a visual of what this looks like. These are total costs, the blue lines, the vertical, back where we can see it. The vertical black lines are the quantity discounts. So you can see very low quantities, we'd pay a lot. After over 10 units, we get a big drop in our price because the transport cost goes down. We still have this decreasing function. These all, up to this point at least, are following the same basic curve. At 20 units, we get another discount, so the price jumps. At 40 units, we get another discount. Somewhere in this area is where the EOQ is. There's the minimum point. You can see this function starts increasing. Up to that point, everything's decreasing somewhere in here. You get your minimum. At 100 units, you get a discount on your price. So you still have an increasing function. So 101, 110, 150 would be more expensive than 100, but 100 may be cheaper than the EOQ over here. So it's hard to say exactly on this graph, but you can calculate that. 200 units, you see a drop in the transport costs. 200 is definitely more expensive than 100. Now you can see this curve kind of shifts a little bit over 400 units. This is the point where buying a full truckload, even if it's not filled, is cheaper than LTL. All right, so you get to 500 units. Still full truckload. All right, the reason this line jumps up is because at 501 units you've got 2 truckloads, but one of them is nearly empty. Just trying to be more realistic. Of course, there would be better options. Again, combining truckload and LTL, you could get this to come down a little bit. 1,000 units is a full truckload, so 1,001, you can see the same issue. There are 1,501 units. It's going to be more expensive than 1,500. We switch to 500 units. You see this big increase. You actually should see that increase back here, where you start using the truckload safety stock. So even though you're paying more in transport costs, you may want to use LTL up to 500 if they would accept it. So this actually is going to look a little bit different in a corrected graph. But you can see there are these points where the price could drop down. And you're trying to see, are those points less than the total cost with using EOQ? And that's really the whole point of what we're trying to do. Let's find an easy way to incorporate quantity discounts into our scenario. Okay. Go back to this. So, check all these prices, recommend order quantity. Calculate reduction or increase in average inventory made possible by your recommended order quantity. So for whatever quantity you think is the best, say what's the average inventory? Q/2 plus the appropriate safety stock for that mode of transportation. Then we could also look at what they're doing right now. What they're doing right now, they're using Q of 2,500 to get that quantity discount. They're using a 2-week safety stock. If you read the case, it says they have about a 1 week lead time, but they order when they have 3 weeks worth of inventory. 3 minus 1 is 2, so their current safety stock is about 2 weeks or 150 units, 75 times 2. So you could say, how does their current inventory levels for the television compare to their average inventory level using our recommended plan? It should be a significant reduction. The logic would then be we can reduce inventory on one item by, say, 80%. If we can do that on a lot of items, same people are making the decisions, probably the same type of decisions, we'll have no need to buy a new warehouse. We can see the savings from the new warehouse being less crowded, but we can also get savings on each item, and you can calculate the savings for this item. You can just plugging in their current variables into this. So using $450 transit costs, 1140 purchase cost, safety stock of 150 units, quantity of 2,500. And you can say you're going to save this money on this one item. Logic would say we can save that money on other items as well, or similar amounts. Okay, and so do all that and then write up a report. And the table I want to see is just for these 5 different quantities that you could possibly purchase. What would the total cost look like? What would the carrying costs, ordering costs, transport costs, and purchase costs? So, and total costs. So, like five rows and 5 columns or something. Okay. Any more questions? Feel free to let me know.